going to cover this phase change material, basically how it works, difference between sensible heat and latent heat, why what is the melting point average of 58 degrees? You've maybe heard that if you've been at some seminars or some of these shows that we do, so we can explain a little bit about that. The overview Sunamp, and yeah, we'll start going over the technical aspect, the installer side of things. So history of phase change materials, how it all sort of began. So Edinburgh University back in the 1700s, this chap, Joseph Black, he discovered carbon dioxide and latent heat. So latent heat, that's the sort of hidden energy that can be in a, like steam, for example. If you captured that, that'd be your latent heat. And then that's where he went. So nothing much happened regarding phase change materials then, but latent heat was a big discovery, because that's how the heat batteries work. We use the latent heat aspect to store that energy. But along came Maria Telkis. Now, she was known in the sun as the Sun Queen, so she pioneered the first heat batteries using phase change materials, similar to what we do. And she built this experiment, this project. It was basically a solar house, massive phase change material batteries, so capturing that solar energy to then charge up our heat batteries. Powered this home, as you see here. Heat and hot water, everything's perfect. But the problem is with phase change material is nobody's been able to refine the recipe. In a chemistry kind of in the chemistry realm, nobody could find the components to get that longevity from the phase change material. So this project, it was fine for a couple of years, but the phase change material started to break down, became less effective, and then that was the kind of end of the project. And again, nothing much happened until Sunamp came along. Again, it sort of came full circle from 1700s Edinburgh University back to present day Edinburgh University. And our CEO, Andrew, finished his first successful business. He's one of these guys that can't sit still, so he started tinkering with phase change materials, and he took his concept to Edinburgh University. And it just so happened there was a student there who was studying phase change materials and was writing his thesis on it, and he actually cracked the code of how to get that sustainability from the phase change material. David Oliver, who's still working with us to this day. So interesting bit of history of Sunamp there. So phase change material. So a PCM, or a phase change material, is a substance that releases or absorbs enough energy to generate useful heat or cooling at phase transition. In most cases, the transition will be between two main states of matter, solid and liquid. So when you think about our heat batteries, in its cold state, it's in a solid, when the battery's cold, it's in a solid state. When it's hot, it's in its liquid state. So when you apply heat to that phase change material, it'll liquefy, and then when you cool it, it'll solidify. So it goes back and forward. So there's two types. We use the salt hydrate, the inorganic PCM. So it's non-flammable, non-toxic, and it's readily available. So that's why we use it. So has anyone got any questions so far?
No.
Oh, good. I mean, we're not going to become chemists after this slide. It's just so you have an idea of what's actually inside there. So really, the salt hydrate, what's the phase change material inside the battery? It's the sodium acetate, it's the salt, basically. That's the main component. There's other things in there as well, which we've patented, but sodium acetate, you get that on salt and vinegar crisps. So it's the same thing.
As you're using your energy that you've stored in your heat battery, does it just come to a point where it just stops, or does it come to a point where you're tapping your hot water, reduces the temperature, or does it literally just stop and run out?
So yeah, basically, yeah. So if you're looking at we'll cover this as well as we go on, George. But yeah, if you think about the heat coming out of the battery kind of slowly degrading in a graph and then it'll hit 40 degrees and it'll just plummet.
Okay.
Like that. So we generally use 40 degrees as well, unusable hot water basically, because after 40 it just falls off a cliff.
Okay.
But we'll talk about the functionality as we go. So yeah, I don't want to tell your granny how to suck eggs, but difference between sensible heat and latent heat. So the sensible heat's the heat you can see, so you can see that temperature rise on a thermometer basically, and the latent heat's that hidden energy. So again, if you look in here, the water vapor is your latent heat. Essentially what we're doing is we're capturing that latent heat in the phase change material, absorbing it, which hopefully this graph can explain a little bit better. So the phase change material in water, it behaves the same way as you're heating it up. So if you look at this graph, they're both heating up in parallel up until you hit 58 degrees. Water will continue carrying on up to sensible heat until it gets to that 100-degree mark and it'll start to boil and boil off the vapor. Phase change material, it's sort of at 58, it starts to flatten out and absorb all this latent heat, and then until the capacity of the battery is full, and then it'll just carry on as sensible in its liquid state. So when you hear about 58, P58, that's what we call our batteries. The P58 is the type of phase change material that's in there, and the melting point is 58 degrees. So luckily that's a good temperature for hot water, hence the domestic hot water application. So because of this, we've got 4 times better energy density than water. So that's why we can make the batteries smaller than cylinders. So when you look at a 300-litre cylinder compared to our Thermino 300, which is a comparison, the equivalent, it's much smaller. It's much more compact. So that's the reason why. So the phase change material has 4 times better energy density. So now you understand everything about phase change material. You can explain that to your customers quite happily. And ask you how does it work. So we've got a couple of questions just to see if anyone, hopefully everyone's been listening. So we'll go over the questions. Hopefully you've done well. What type of PCM is used in batteries? What answer did you get there?
Bugger, I put sodium acetate or something like that, but it's inorganic.
Inorganic. So the difference between sensible heat and latent heat. So the sensible is the energy we can sense. Latent is the hidden energy required to convert a solid into a liquid. Is the textbook answer. How many more times denser is PCM to water? You had 4 times. And who pioneered the first heat batteries?
Yeah, 2. Maria Telke.
Yeah, Maria Telke. So it's just a wee stomach tightener for 10. So generating hot water differently. So your traditional cylinder disadvantages. So longer heat up time due to this coil surface area, pressure drop. You've got the line scale build up over time. That'll decrease your hot water production. Immersion here directly in the hot water. A Legionella cycle as well is required. Unvented system kit. So you've got G3 building regs to see to there. Certainly in the UK. I don't know what it's like overseas. Which means you'd have to have a qualified unvented engineer with an unvented ticket. So whatever, if the customer's getting their boiler serviced, for example, or if it's a direct cylinder, they'd have to have someone in just to check the expansion vessel, check the temperature pressure relief valves working correctly and stuff. And obviously you've got multiple coils, and obviously the size of the thing as well. As you come down to our heat batteries, so that's our 4 sizes there. So that's our smallest. Height-wise, it goes up to 440 millimeters. To our tallest, the Thermino 300, which goes to just over a meter. When you look at the 2 comparisons there, that's a 210-litre cylinder versus our Thermino 210. So you can see the size difference there. And that's, just sort of gives you that good sort of comparison. So this is just in our experience room. If you ever come to the factory, you've maybe seen this, and that's one of the first things that the sales reps want to show you. So it's quite a good comparison. So you've got, that's our biggest size there, our Thermino 300. So it's just over 1 metre tall compared to your 300 litre cylinder. The other interesting point about your cylinder, its operation really, your cylinder stat's going to be fitted about here. So if you think about that, we're relying on stratification. Boom, and that's when your cylinder reaches temperature. You've basically got the bottom third of the tank not really being utilised, haven't you? Whereas the way the phase change material works is every inch of that cube is getting filled, is absorbing all that energy. Because the PCM, it's quite pliable to heat. If you add heat into it, it just sucks it up. You know, so that goes to every corner of the cube there. So we've not got any mandatory maintenance on the heat pad itself. There are some plumbing components that may require maintenance over time. So we can work with air source heat pumps, grid electricity, solar PV, gas boilers as well. District heating, any heat source. There's no inventory certificate required. We're fully recyclable at the end of its lifespan. So it's, when we talk about cycling, that's basically turning the element off and on and heating the thing up and discharging it. So they've tested it. This is what I was saying about the phase change material being very durable. So they've tested it up to a 50-year cycle. So that's on and off, charging it and discharging it, and it equates to like 50 years. So if you take that charging and discharging twice a day, you know, they've done that. Obviously, they've not waited 50 years to do it. They've rapidly tested it, but there was like I think after the cycling, there was like a 2% degradation or something of the phase change material, which is pretty impressive. We offer a 10-year warranty to the product. Sorry, was there a question? Sorry.
No.
Just a cough. Like myself. We offer a 10-year warranty to the product, to the phase change material, the heat exchanger, and the element as well. The rest, the electrical components, will be a 2-year warranty, but the main crux of it's 10. So there's no minimal moving parts. We do have some moving parts electrically, but the actual process of charging the phase change material internally there's no moving parts there, and there's low risk of Legionella. So even with our tallest unit there, we're holding about, I think it's 12.7 litres of water in the heat exchanger. So it's only, so if memory serves me correctly, less than 15 litres do have to comply with Legionella cycles in a unit. And we're not a cylinder, we're not storing water. Like you're storing water here. We're using the phase change material as our store. So think of this like a thermal store. And we've got a cutaway that we can show you as well, just to explain that a little bit better. So this is our CEO, Andrew Bissell. He's basically started up Sunamp back in 2005. So yeah, we're almost coming up to our 20-year mark where the company was founded. So yeah, we're certainly going places, thanks to Andrew. So as you can see there, we've started to get, obviously we started in the UK, but we're starting to sell it in North America now. We've got stuff going on in South America as well, and we're distributing to Europe to different OEMs and stuff as well. So it's quite an exciting time to be part of the company. And that's just some accreditations that we've gained over the years, RAL, Kiwa, and the King's Award, that was this year. We were awarded that, so for innovation. So obviously we're being recognised for the work that we're doing. So we've got some more questions. Hopefully I covered them. Sorry. I'll let you all have a look at that one again. Based on the questions, we've kind of rattled through that. And then obviously your King's Award. I will go back a little bit because there's quite an important thing that I wanted to mention as well. So when you look at this, that's basically, that's corrosion of your element in a cylinder. Our battery, we don't have that electrolysis effect because the elements are embedded directly into the phase change material. And, when they've been testing them, they've stripped them out. There's no degradation on that element whatsoever, so there's no electrolysis effect from the element being directly embedded into the phase change material. So you don't get any of this limescale build-up and things like that. So based on that, some questions for you guys. So can anyone name 2 cylinder disadvantages compared to the heat batteries?
Legionella.
Size.
Size, yep.
Bit of a G3 certificate.
That's the one. Yep. Okay, perfect. What about how many years was the testing cycle tested for?
50.
50 years. Yeah, spot on. Perfect. Name 1 accreditation the heat batteries have been awarded.
The King's Awards.
Perfect. Yeah, perfect. What effect on the element doesn't take place in the heat batteries?
Electrolysis.
Yeah, spot on. Oh, yeah, obviously, any of those you've want to watch, yeah, and that's perfect. So